API, and tool lists as managed context. A model can choose a completely irrelevant tool because its parameters look compatible with the request. The argument shape fits, but the action is wrong. With hundreds of capabilities, that is a context design failure before it becomes an execution failure. I'm Mehrdad. In this video, I'll show you a 5-stage architecture for managing tool context: catalog, retrieve, inspect, execute, and retain. A tool list is not free configuration beside the prompt. The model receives a representation of callable names, descriptions, and parameter schemas before it can select an action. Providers may also add tool use instructions. After a call, arguments, results, errors, and retries can enter the continuing interaction. All of that competes with the user request: evidence, reasoning, and answer. The exact serialization differs by provider, but the durable point is simple. Definitions and results are model-visible context, and they need a budget and a lifecycle. If this is useful, like the video, and subscribe for the rest of the context management series. Consider a customer operations assistant connected to customer records, orders, shipping, payments, refunds, fraud checks, tax, services, and messaging. The user asks, "Where is order 4821? And is it eligible for a refund?" Showing every tool creates 5 costs at once. Selection gets harder. Definitions consume input. Larger requests can add latency. Dangerous actions become unnecessarily visible, and constantly changing the menu can reduce cache reuse. There is no universal safe tool count threshold because schemas, models, and tasks differ. The goal is the smallest useful capability frontier for this request. Token cost is only the visible symptom. Imagine 4 tools. Check refund eligibility, create a refund, reverse a payment, and cancel an invoice. Their inputs may all contain a customer identifier, an amount, a reason, and an order reference. Strict argument validation can prove that a generated call matches one schema. It cannot prove that the model chose the semantically correct action. Research on structural alignment bias shows how an irrelevant tool can attract a call when its parameter structure aligns with the request. Near duplicate tools create another problem. Descriptions may differ by one precondition or side effect. That means retrieval must preserve the required capability, selection must distinguish intent, and the executor must still enforce policy. A clean JSON object is not evidence of a correct business decision. The solution is progressive capability disclosure. Start with one canonical catalog outside the prompt. First, filter it by identity, tenant, policy, and environment. For our order question, the assistant sees the orders and shipping domains, not every company integration. Second, retrieve candidate capabilities from those authorized domains. Tool retrieval is specialized retrieval. User language and tool descriptions may not share the same words, and multi-step tasks can require capabilities that become obvious only after earlier results. Third, inspect full schemas only for likely candidates, such as orders get and shipping track. After the order state returns, retrieve refund eligibility. Keep refund creation hidden until eligibility is known and the user confirms the action. Provider-native tool search can implement parts of this pattern where supported, or your application can implement discovery itself. Either way, measure retrieval completeness. A tiny active set is efficient only if it does not hide a tool the workflow actually needs. Keep one canonical capability registry, then compile it for each provider. The registry should own stable names, versions, descriptions, input and output contracts, preconditions, effects, required scopes, approval class, and result size expectations. OpenAI, Anthropic, Gemini, and MCP expose different schema contracts and tool control mechanisms. Even when they all use JSON-like definitions, supported schema features and wire behavior are not interchangeable. MCP standardizes how a client can list and call server tools, including structured results. It does not decide which tools should be visible to the model for this customer and request. The portable design is the registry and admission policy. The adapters are provider-specific, versioned, and tested. Retrieval cannot rescue a catalog whose tools are indistinguishable. Avoid generic names, such as process request. Name the action and object. Refunds check eligibility, refunds create, and payments reverse. Describe both use and non-use conditions. Replace open text with typed identifiers, enums, units, and bounded fields where the business contract allows it. State preconditions and effects explicitly, including whether the tool only reads, or whether it can send a message, move money, or change order state. Define outputs for the next decision, not as an uncontrolled document dump. Examples should resemble real requests without embedding secrets. Good schemas reduce ambiguity for retrieval, selection, validation, observability, and human approval. They do not turn descriptions into enforcement. The model should generate only the arguments it must reason about. The host already knows the authenticated identity, tenant, credentials, allowed scopes, environment, and policy version. Inject or resolve those values outside the model. Then validate generated arguments against the active schema and current business state. For write operations, the execution broker can add a server-recognized item potency key, so a retry does not accidentally duplicate an effect when that API supports it. Do not ask the model to invent credentials, grant itself access, or implement item potency through pros. Tool annotations such as read-only, destructive, or idempotent can improve selection and user experience, but they remain metadata. The boundary is enforced by the host and the target service. Execution does not end the context problem. Tool results may be huge, stale, untrusted, or shaped for machines rather than the next model decision. Validate the response, sanitize unsafe content, and project only the fields needed now. For order tracking, that may be status, carrier event, expected date, source record, and as of time. Preserve the request identifier, truncation state, error category, retriability, and whether any side effect occurred. Keep a handle to the complete raw artifact outside the prompt for audit or later inspection. Then choose a retention rule. A small result may remain for the next turn. A bulky payload may be replaced by a typed summary and citation. Ephemeral data may expire. Compaction can save space, but it is lossy and cannot replace the audit record. Results are temporary working context. Durable consequences and provenance belong in durable state. Put a hard execution boundary after model selection. The model proposes a tool and arguments. The broker authenticates the caller, checks tenant and scopes, validates current preconditions, and decides whether approval is required. Only then does it execute with least privilege credentials. The result must report whether the action completed, failed before any effect, or produced a partial effect. A timeout alone does not prove that nothing happened. Log the proposal, policy decision, approval, request identifier, response, and final side effect state. In our example, checking eligibility can be automatic. Creating the refund remains unavailable until eligibility passes and the user confirms. The model plans. The broker controls reality. Evaluate the capability layer as a system, not only the model's final call. First, measure selection, authorized candidate recall, correct tool choice, abstention when nothing applies, and resistance to near duplicate or structurally compatible distractors. Second, measure execution, argument validity, dependent and parallel workflows, permission denials, error recovery, duplicate prevention, and partial side effect reporting. Third, measure context, visible tool count, schema tokens, search latency, result size, truncation, cache behavior, and end-to-end cost per successful task. Include workflows where the required tool becomes visible only after an earlier result. Compare the full catalog, flat top K retrieval, and authorization-aware hierarchical discovery. Public benchmarks cover useful categories, including irrelevant tools and multi-step execution. But your business policies and proprietary effects still require workload tests. So, treat the catalog as a dynamic capability layer, not a static prompt appendix. Catalog one canonical contract. Retrieve only authorized candidates. Inspect full schemas when they become relevant. Execute through validation, policy, approval, and least privilege. Retain bounded results with provenance, then compact or expire them deliberately. Show the smallest useful capability frontier. Enforce everything outside the model, and treat both definitions and results as managed context. If this video was useful, subscribe to Multi-Agent Academy and connect with me on LinkedIn. I'll keep publishing evidence-backed work on agentic systems. In video 4, we'll go beyond tool retrieval, because context management is bigger than RAG. I'll see you in the next one.